Hey, welcome back to the Lava Academy podcast. I am your host, Ian McKinnon, former primary school teacher, Scottish, now playing with lava for a living here in Reykjavik. Yay! And I am joined by my faithful co-host, Ragnhildur Ágústsdóttir.
Yay!
Yay, indeed.
Nice to be here.
And got another fun one this time.
Oh yeah. I love it when we have people who can dive deep, go into the depths of science, but at the same time explain things really well to those who may not have the deep understanding.
Yeah.
So I think this will be a good one.
This should be a very good one.
Yeah.
So,
And actually, one more thing.
Oh, yes. Oh, Here we go. I forgot about this.
Yeah.
Here we go.
So we did get a little suggestion from one of our faithful listeners.
We did.
And the suggestion was to bring about a explanation bell. Ding! So basically, this is not a novel thing. This is stolen from somewhere else, but doesn't really matter. We think it's a great idea.
We'll take good ideas and redeploy them.
Yeah. And the idea is essentially that, if we hit that bell, it means that there's a topic, word, concept that needs a little bit of an explanation.
Yeah.
So if you hear the ding, you know what that means.
Excellent. So we'll put the bell back down there.
Yep.
And I think we should get on and meet our fantastic guest.
Can't wait.
Welcome back to the Lava Academy podcast. And welcome to our fantastic special guest today, Helga Þorvaldsdóttir.
Thank you.
So Helga is, a PhD candidate, I believe,
Yes.
doing volcanology and petrology?
Yes.
Question mark?
Yes.
And also has a fantastic little Instagram thing going on there, Geology with Helga, which is super cool. Welcome.
Thank you.
So why don't you tell us just first of all a little bit about yourself, your background, where you're from, and what on earth got you into all of this
What on
geology
earth?
business? Oh, see what I did there? That was intentional, folks. So how did you come to get into this whole geology thing in the first place?
Yeah, it's one of those questions I don't really think of until someone really asks me.
Mm-hmm.
It's quite funny, but I've always been quite a nerd. Very interested in nature, science.
We love nerds.
Yeah.
We are nerds.
We are nerds.
And as a kid, I was just always wondering, sitting and wondering about nature. Why is the sky blue? Kind of concept. And then as a kid, I was gonna become a police officer on a motorcycle. Very
cool.
very specific. What's the head of police department called again?
Lögreglustjóri.
Yes. I have such a pregnancy brain. I can't really remember things, like simple words. So yeah, this podcast might take quite a while because of that.
That's all right.
But yeah, as a kid, I have a very focused dream of becoming a police officer on a motorcycle. And then I was going to become a bus driver. And just as a kid, you just fluctuate. But then
I can imagine you on the Strato just charging, 90 kilometers an hour down.
But then I was very goaled in becoming a doctor, like a cardiologist or something. My parents are both doctors, and I love anatomy and just how that science goes. But then when I got into high school here, Menntaskólann in Reykjavik, from the first geology class, I was like, this is my department.
Mm.
Didn't really know that it was a subject, basically, but all my interests combined there. So nature and just space and all of those things.
So it was an immediate fascination.
Yeah. And didn't really look back after that. So it was just clear that geology was my thing. And then I wanted to be very specialized, and I just want to stay in research. And discover things. Like, I want to be the person that discovers. I just can't just sit and read and be like, oh, good for you for discovering. I'm like, I want to discover things too.
Yeah.
So yeah, just all of those nerdy stuff combined there.
Yeah. Now, one of the main reasons that we could have got you in to talk about any number of different things, but one of the things that we really wanted to get somebody to talk about was one volcano in particular,
Mhm.
and it is a volcano that you have a particular
Mm-hmm.
connection or affinity with, perhaps, I
Yeah.
don't know, or interest in at least, and that is Öræfajökull.
Yes.
So what drew you to studying that volcano in particular? I mean, let's face it, you're spoiled for choice here. You could have
Yeah.
chosen any number of them.
Exactly. So for my bachelor's thesis, I wrote about Eyjafjallajökull.
Mhm.
And then masters went into Öræfajökull, and now PhD I'm continuing with Öræfajökull. And it's our most dangerous volcano here in Iceland, and it's also one of the most overlooked ones too, because it's so silent and sneaky.
Yeah.
Yeah, that's the thing. We don't tend to hear an awful lot about it. We mentioned it not long ago. Was it when we had Stjörnusævar on?
Stjörnusævar was
Yeah.
here, and he was talking about how he adores that volcano.
Mm,
Yeah.
So you share that.
yeah.
But I think also because, for instance, in our show, we have a short video that
Yeah.
explains a few of the biggest catastrophic eruptions in Icelandic history. And one of those is from Öræfajökull,
Mhm.
the one that you specifically
Yep.
study, the 1362.
Yeah.
And I mean, being Icelandic myself, and, when we have Icelandic guests, very often after the show, we hear the comment, I had no idea.
Mhm.
So even the locals don't really know that much about that volcano.
Yeah.
Why is that?
Everyone is in denial. No.
No, I think maybe, but I think it also, it doesn't erupt that often.
No.
But it's also there's others that have sort of gotten the attention more,
Yeah.
Mm-hmm.
that are more frequently.
Still in the limelight.
Yeah.
Yeah.
So tell us a little bit about Öræfajökull.
So during historic time, it has only erupted 2 times. It was in 1727, which is the most recent one, and then the 1362. So we only have 2 historic eruptions, and then many before that. So it's usually the ones that have erupted quite often during historic times, like Hekla, for example, that get a lot of attention, and then that sits in the brain of people, basically.
Yep.
Or something that's recent, like Katla 1918 or so. But other than that, also Öræfajökull is quite far away from the capital area, so that might play a part. And it's not on the main rift area of Iceland, because we have these 2 tectonic plates that are pushing apart, and the volcanoes tend to align on that because they use that activity. But Öræfajökull sits quite far away from that, similar to Snæfellsjökull in the west.
Mhm.
So those 2 are a bit different in terms of the very regular volcanoes in Iceland. So it's often very forgotten, and also there's less earthquakes happening there because they are outside of this. So as soon as you can go on the Met Office site or a website that shows all the earthquakes, you see it all aligns through the center of Iceland where all these volcanoes are, and then there's quiet over at Öræfajökull.
Is there a rift zone there?
Maybe an old one or maybe a new one that's forming. They are usually called, or it's still debatable if it's an embroic rift, very technical term, meaning embryo, it's something new
Just
starting.
a little
Yep.
baby rift starting to form.
So the east fjords and the east of Iceland are quite different from the west or so. There is something unusual going on underneath there, maybe a fragment underneath from Greenland or so that's playing a part because the east sits much higher. And then they could be we have Öræfajökull and then Esjufjöll and then Snæfell north of Vatnajökull glacier, and then Esjufjöll is in the middle of Vatnajökull, and Öræfajökull is sort of at the base of the Vatnajökull glacier. And you could draw a line between these 3 points, and potentially you have some kind of a seam there a scar or something that is playing a part in the activity.
But why, like, I mean, given that Öræfajökull doesn't erupt that often and therefore isn't maybe as much, being talked about, what drew you to researching Öræfajökull?
So it's also in like collaboration with the advisor you have. Like he has like a topic or something, and then you sort of start to dive into that, and you're like, yeah, I want to do this. Like I myself didn't necessarily come up with it, but I still have like plenty of research topic now that I want to dive into later. But as a student, you either get to know a topic or you like come into an arrangement from the advisor.
It's a little bit like how you came into the geology thing to begin with. You weren't really aware of it until you were. And when you were, it was like, oh, okay, this is the thing.
Right.
Yeah. Okay.
That's a good point.
And then you start, like for me, it was the master thesis. And you started with a very simple idea maybe. And then you start researching and come across things. And then you see, okay, this is getting more detailed and this, and you maybe answer one question and open up 10 more questions, and then you're like, okay, I'm just at the tip of the iceberg here, and you go deeper and deeper basically, and now ended up in the PhD because it wasn't as simple as we thought in the first place.
Okay. All right, so let's kind of scroll back through time and let's take ourselves to that area which is now known as the Öræfi area district, before that 1362 eruption. So what would that landscape and that community have looked like at that time? Do we really know?
It would have looked like it does today. Very green and peaceful little hobbit land. Very
like
cute.
The Shire.
Yeah, the Shire. I call it the Shire.
It's Little
it was called the Little Shire.
Little Shire, yeah.
Very cute, a lot of farms. And when you start reading that description, you're like, you are basically describing how it is today. So in the meantime, after the 1362 eruption, it was just like a desert, basically. Uninhabitable for 40, 50 years after the 1362 eruption. So we had an eruption in 1362 and then 1727. There's roughly 300 years apart. And now we are 300 years apart from the 1727 eruption. So
you're telling us we should start shaking?
I don't know.
Well, at least I think that, it has been discussed a little bit in the media and, amongst scientists that, at least it's like showing some signs of stirring. Like it could be still very early. There could be decades still. But, there's something brewing.
So in 2016, 2017, around that time, there was an activity. It's trickier in Iceland. We have usually glaciers on top of the biggest volcanoes because of their height, their mass. So the surface of the Öræfajökull glacier started to melt and we got this cauldron. So there was something heat happening from the below. Was it geothermal heat? Was it magma? What was it? Something triggered it because you need a lot of heat to melt glacier. And the cauldron was, I want to guess, 65 meters across. I don't remember exactly.
Yes.
But it was very noticeable from satellite images. And so something happened. It was just not out of the blue. Most likeliest outcome is that there was a magma injection near the surface of the crust, which then melted the glacier, but nothing really happened more after that.
Yeah, it didn't lead to an eruption.
No, it didn't lead to an eruption. Maybe it was a little surface eruption under the glacier that we don't
below
know
the glacier. Yeah.
Was there an associated jökulhlaup with that one?
Yeah. I don't remember. Maybe there was some increase in the rivers. There's a lot of rivers coming out of the outlet glaciers, but not like a significant
cataclysmic flood or any sort. No.
Yeah, just for the sake of the audience, jökulhlaup. Oh,
there you go. Hey.
So let's explain jökulhlaup.
Yeah.
It's an Icelandic word that has claimed the international word for it, but when we try to explain it in English,
Yeah.
we would say what? Glacial flash flood?
Glacial outburst flood.
Glacial outburst.
Yes. Very flash flood of the sudden ice melted.
Yeah.
Yeah.
And this happens frequently in Iceland.
Yeah.
Because, as you said earlier,
Mm-hmm.
more than half of the volcanoes,
Mm.
and especially the bigger ones,
Yeah.
happen to be under glaciers.
Yeah.
So there's this interaction between
Yeah.
lava and ice.
Yeah. Not a good
Leading-
combination.
Not a good combination, no.
No.
So some activity awakened, and since Öræfajökull is not on the rift, it's so far out outside. It's 50 kilometers away from the rift in Iceland. There's one explanation that could trigger melting like that, and that is magma. So there was something brewing underneath there.
Mhm.
So Öræfajökull is waking up a little bit. If we take its little brother, which is a little bit closer to rift, it's Eyjafjallajökull, which we all remember. Same thing happened in 1999. There was this injection, melted the ice a little bit. There was some visible land lifting there. And then almost 10 years later, we got the eruption in 2010. So it's like you have this timeline of the warning there and then the eruption. Maybe we could apply that same method for Öræfajökull. However, Öræfajökull is much larger, much colder because it's so far away from the rift. And it's like you find an old tractor in a barn and you have trying to...
And you get it back
Yeah.
into life again. It's going to
So-
take effort.
So maybe we could apply 20 or 30 years, but it's still jumping to conclusion. But we could maybe apply the same method, but we have to extend the timeline.
Yeah.
Okay.
So let's go to that 1362 eruption. We've painted the picture of basically
The Shire.
The Shire,
The paradise area of Iceland.
lovely green rolling hills, and a bunch of Icelanders going about their farming business.
Yeah.
What happened?
What happened? So a little bit annoying is that there was a bunch of files about this. Farmers and priests of the time were very good at noting stuff.
Okay, because I was actually going to ask you about,
Yeah.
when I was asking about the kind of, setting the scene thing, like what sources we actually have for what was going on at the time.
But the thing is,
Oh dear, this
the thing
does not
is,
sound good.
we're so influenced from Denmark that they want our scripts and stuff, so it was like being moved around and it sank with a ship.
Oh,
no.
really?
So annoying.
And we know this for a fact that
Yeah.
like descriptions of what was going on there at
yeah,
that time.
I need this information for my thesis.
Oh,
That's
okay.
horrible.
I know.
So
A
it
bunch of other
survived
things.
all through everything, and
Yeah.
then somebody just decided, okay, let's just take it for a little holiday to Denmark.
Yeah,
And
or the other way
Or
around.
the
They
other
were
way
coming
around.
back, but
Yeah.
they shouldn't have left the country to begin with.
Yeah. Okay. But so we do not have all the information that was actually recorded.
No.
But what do we have?
We do have some, of course. There are some old scripts here and there, but it's very limited. Like, I'm like reading very old stuff, and there's like 1 or 2 pages here and there. But we know. I don't really know much about the days before the eruption, but I just see it in my data, the development, roughly. I can't go into too much details because it's not published.
secrets.
Mhm.
Yeah.
But I guess if I would have just want to apply modern kind of seismicity and stuff to that, there must have been some activity some weeks before. But earthquakes, maybe some steam here and there or something, that would have been written down of
Yeah.
someone.
So basically, there should be some signs
Yeah.
in the weeks and maybe months leading up
Yeah.
to the eruption.
Yeah, it's that big of a volcano. There must have been some kind of signs, but at the time you blame it on the gods or something.
Yes.
Or like, for example, the eruptions on Reykjanes, we wouldn't know of them if we had been there because they're so just hidden.
Yeah.
But you would have seen a red glow, and then that's just a dragon. You shouldn't go there, So like at the time, they just simplify things because they didn't have the science. So those explanations, you don't really have that. There are some really good explanations. For example, if we take Hekla, for example, there's like hills around Hekla, and there was this farm area, and they wouldn't see Hekla because of a hill. But as soon as they saw her peeking up above a hill or something, then they knew that she was going to erupt because she was like inflated.
Yeah.
It was just like this
Bulging.
Yeah.
Yep.
So those kind of foreshadowings, or if Katla would go off, the farmers would know days prior because their silverware would get black. So that was their like indication. Because of the sulfur in the air, and they were like, "Oh, Katla's gonna go off. Our silverware is like not silver anymore." So those little instruments work.
So people living close to volcanoes should maintain using silverware and not the modern, fake ones.
It's, it's a bit like the canaries that you used to see down coal mines. If the canary died, it's like they're getting into dangerous territory and trying to get out of there. Yeah.
But these kind of call signs from 1362 eruption or 1727 eruption of Öræfajökull don't really have that information.
No.
Well, from the 1727, they are, I think, 1 or 3 people died in the Jökullaup, the flash flood, on a horse or something. And the longevity of that eruption was a few months or something. Those information we have, but...
Yeah. Like the broad key
stuff,
but not the details. Not like there was a steam coming up there. There was like a tremor that time, that day, stuff like that. Okay.
So there would have been some sort of indications that something was afoot.
Yeah.
And then bang.
Boom. Bang, yeah. Or
okay.
Boom.
what kind of a bang or boom are we actually talking about? I don't want you to copy it. I mean, it's like what to the observer what would that actually have looked like?
So this is the tricky part because we just recently dug through the whole tephra section, meaning the deposit from the ash cloud or just the eruption, and there are a few things to consider. We have Jökullaup, which is the flash flood after the ice melts. There are of course just regular ash falling in different sizes, big blocks or small or just fine-grained.
Because the lava gets in contact with ice and fractures,
Well, yeah, in this case, because it's an explosive eruption, it's very silicic.
Yes, true.
Like it's not the liquid flowy basaltic ones that you have here.
Yes.
Thank God. But it's the silicic one, which is more fragmented, or how do you say? It's like the froth on the beer.
Yeah.
You get the top there. You erupt the beer froth from the beer.
So what? Yeah, just kind of drill into that a little bit. So the type of lava makes a significant difference to the type of eruption you're going to get. So the basaltic lava that is most common around the capital area here near Reykjavik, and actually most of Iceland, is going to give you a much more gentle type of eruption, given the right circumstances, of course.
Low in silica, not in sour.
And that's all, so silica content is the key to this. Yeah. So we're talking there rhyolitic lava.
So there are like the chemistry part of volcanology, which is my specialty, is that different elements control different things in magma. So we could divide magma broadly into 3 categories. We have the basaltic one, very liquidy, very warm. It's like very raw. It's like the starting material. So it has low silica content. Silica being the element in the periodic table. This one is the one that controls the most things in lava and magma. Magnesium is the second most important one. So low silica content, you have liquidy, you have very warm hot magma. Then you get into intermediate. That's like a trash can kind of situation. Let's not stay too long there. And then we have the other aspect, which is the rhyolitic one. It's very evolved, meaning it has been through stuff. It started out as the basaltic, low silica one, and then has gone through some stuff. It's like warming up the same soup every time. It gets different a little bit. So you get different composition. It's been through a lot. It has seen a lot of stuff, and it behaves differently. And you need a magma chamber to create the silica content, meaning from
high silica content.
Yeah. So you need because that one is much lighter. It sits on the top in a magma chamber because the heavy minerals have sunken down. So
so the heavier elements are sinking down to the bottom of the chamber. So the relative amount of silica in the upper part is higher.
And that's what explodes.
Yeah, that's the dangerous magma. So that's why we get explosive eruptions from central
volcanoes. It's much more
volcanoes.
viscous lava.
Yeah. So that's why we get these explosive eruptions from central volcanoes. You need a magma chamber, you need a big volcano to create this. And this is the part that erupted in 1362. So the magma, we didn't see like a lava fountain. The magma just went straight into ash, fragmented because it
just
exploded.
Completely blown apart.
Yeah, so it completely exploded. So that brings me back to these three categories of catastrophe. There was the glacial outburst flood. There was just ash fall. That's a catastrophe of its own. And then the pyroclastic density currents. Should I ring the bell?
Yes, let's ring the bell. Let's explain that concept because it's important in this context.
Sure is.
Yes. Pyroclastic density currents, or PDCs. PDCs are not funny at all. We're not. This is a nervous laughter. No, PDCs are when we have these eruption column, the ash plume, it collapses because the eruption opening maybe widens because of the violence, and then it can't sustain, and then it collapses. You can't really calculate in what direction it collapses. It's very random. Wind might influence it, the direction of wind maybe, but it's very random. So when an eruption column collapses, forming this PDC, it rushes down the mountainside and it's extremely hot and travels very fast, and it's like an eraser. It just erases everything in its way. And that is what killed most of people in 1362.
When we're doing the shows here, I quite often have to try and explain this to people. And the best I can come up with is like it's a reverse mushroom cloud.
Yeah.
Like from a nuclear explosion. So it's just
it's not dramatic at all.
No. And it is basically the same effect ultimately. Because as that just kind of comes, it's just and heaven help anybody who's in the way of it.
But regarding the 1362 eruption, the order of these are the most important part regarding the future. So so before it was just considered that the Jökullhlaup were the main catastrophe. So in case of an emergency now, the Jökullhlaups, they go where the outlet glaciers are, the smaller.
Yeah, they're following the channels that water's already coming from. Yeah.
So there was these evacuation areas between the outlet glaciers. Okay, cool. That is if the Jökullhlaup is the main threat to gather at these points. And also if the Jökullhlaup is the first thing. But where would we gather if it's the PDC that's the first thing? Like, where do you know where to stand?
Do you never talk about it as pyroclastic flow? Is that not the right terminology?
No, you can, but it's just the scientific way. It's the PDC.
Okay.
Yeah, it's basically the.
So what you're saying is that, if that is the first thing that happens before the flood, before, we have the Jökullhlaup. Then of course there's other places where you would have to evacuate. If you can.
The arrow should be like this, away from the area. Just evacuate. To the east or west. Do not gather at these points where you would skip a Jökullhlaup.
Just leave.
Yeah. So we saw that in a section a few years ago that the PDC came first. So not the Jökullhlaup. So meaning the evacuation protocol changed to just leave,
Clear off. Yeah.
clear every area, basically.
So
Hang on. Just before we go,
Yeah.
how far away would you have to go?
yeah, it's a good
Oh
question.
yeah.
Because
That
those
depends.
things can travel quite a distance.
So the PDC generally they stay within like the radius of the volcano, but they extend quite far though. So the 1362 one, it went straight south, but unfortunately for us volcanologists, straight south is the ocean, so we can't really look at the deposit later on. We have a very narrow window of maybe digging it up. But I mean, the volcanic plume from the 1362 eruption in total was 30 kilometers high, but I'm not sure at what height the plume collapsed though.
Yeah.
But I mean, how far you should go away? That's
As far as you can.
it would have been easier if it would go east or west, and we would see how long it was.
Yeah, because you
in
could get that
total.
from the tephra deposits, right?
Yeah.
Yeah.
But 100 kilometers or something, just east or west, basically.
But what about that, 1727 eruption? I mean, did it also go south that time?
Yes, so it was the origin. It's more in the flanks or like the side of the volcano, very similar to the Holuhraun eruption in 2014. Right. Like it was, there was fountaining, but it was not pure basalt. It was more evolved, so it was a bit explosive, but it left like tephra cones, which now have been like sort of erased from the glaciers.
But was there no PDC for that particular?
No, because it was. It's a different kind of magma, but there was jökulhlaup from it because it partially went into the glacier. So it was like a row of craters, few being exposed, and then few under the glacier.
The reason why I asked was because you were saying basically that the data that you have from the 1362 is so limited when it comes to the PDC.
Yeah.
So, you can't really answer the question how far you would have to go. And I mean, back then, the means of transportation was walking or on horseback. So like you there was a limit to how fast you could get far away.
Yeah.
Is it correctly then understood that, if this were to happen again and there would be a PTC, that would likely be the first thing to be aware of, to run away from before a jökulhlaup? And could it go in all directions? Like, is it just a matter of coincidence, or is it more likely to go south? Do we know this?
So the direction is very coincidental, but you don't really run away from a PDC. You just stand, really. It's a matter of a few days before, like, okay, Öræfajökull is waking up. We know that the first thing happened was the PDC, so evacuate the area. And then jökulhlaup and all of that follows. But if the eruption has already started and based on history that PDC follows quite soon, then I mean,
try and get away.
Try to get away, yeah. Maybe I think wind direction could play a part at some point if it's strong winds, but not really.
There's one thing that I find extremely fascinating about this particular eruption, which I don't think necessarily a lot of Icelanders are aware of, is that before this eruption, because now we call this volcano Öræfajökull, but that was not what it was called before that particular eruption. It was called Hnappafellsjökull.
Button Glacier.
The Button Glacier.
So cute.
And I think, just the fact that it changed name, we sometimes joke around here at Lavasjó, that we call it the volcano of ruined wasteland. It's very dramatic. But I mean, essentially, it was so disruptive and so catastrophic that, the volcano got a new name because of it.
Yeah, that takes some doing to actually get people to rename an area or a thing that stood for however long.
So I actually want to ask you, because you said earlier that just the ash plume or the plume went like 30 kilometers into the atmosphere. I mean, on a global scale, if we go beyond Iceland, how big is this eruption?
Very big. That's like the It's the biggest eruption since Pompeii from Vesuvius. Was it 79 BC?
Yeah, or
Yeah.
79 or 80, yeah, something like that. Yeah.
It's
This
quite a
is
lot.
basically a huge, enormous
Yeah.
eruption by even global
Yeah.
standards.
Maybe if we take into Tonga or Krakatoa or something
no,
like
not
that.
the super volcanoes.
No, yeah,
No.
or Yellowstone.
Yeah.
But yes, for the northern hemisphere ones, this is quite a dangerous volcano.
So let's go back to situation
very
on the
gloomy.
yes, situation on the ground then.
Yeah.
This thing blows its top.
Mm-hmm.
This blast of gas and heaven knows what else comes charging down the mountainside. Then we get the outburst flood as well on top of all of that. What does the area look like once that has all taken place?
Like a dusty Sahara desert, basically. Because the tephra is very lightweight, it's light colored, it's beige to almost white. So if you apply that to all the area, you don't have the black sand classic Icelandic look. You have a dusty desert kind of, and then a lot of fine particles in the air too.
So are we talking like total annihilation, basically?
Yeah, it's the whole area, and then slowly later, few decades later, you get grassy areas on top of that, and then soil. So you don't have to dig very deep into the ground to just expose the whole section. It depends on where you are, because, of course, it's a very dynamic area today. There's still glaciers and rivers, and they are messy. They wipe everything away from the surface. So the top part of this tephra section is missing in most cases.
Yeah.
Too.
It's like those Etch-a-Sketch toys, you draw on the top and then you just wipe the top layer off.
Yeah.
In some places, there like soil that preserves this, and the biggest area, the biggest tephra section I've witnessed from this is 3 meters high.
Meters.
Yeah, and then the top is still missing a little bit.
That is.
Then you have the eruption
3 meters.
timeline, basically.
And like, what distance from the kind of center of the thing was that 3 meters?
That's in the flank area. It's close to the source,
it's really
basically.
close.
Yeah.
Can I gotta ask just some very direct question. Like, researching this particular eruption so thoroughly and, learning all these things. I mean, obviously you're fascinated about it, but to what extent does it make you like more afraid or like sort of respect the powers of nature?
Definitely more the respect part. You're like, damn. And then you look at the volcano, you're like, you did this.
Yeah, you're a badass.
So like, no, but then applying the same method everywhere else in the world. Like, for example, I was going to take a vacation with my boyfriend. We went to Tenerife. We just wanted to take a break from studies, and then you land on Tenerife for the first time, and I'm like just jaw on the floor. Like, people building this stuff, like those tephra sections are nothing to compare to Öræfajökull. There's long and just like a roundabout, and you have a huge tephra section of PDCs, and I'm like, you guys,
are you aware?
You see this? And you just build here. Then you just realize, okay, I can't really take a break from this anywhere I go. Yeah. Same with my advisor. He was like, oh, I need to take a vacation. I was like, oh, I went to Sicily. It was so nice. No, it's too much geology there. I was like, where can you go? Oh, go to Florida. It's just like swamp area.
Yeah. Nothing happening. I mean, of course, geology is everywhere where there's earth. But, we sometimes talk about it here that, when the Vikings came to Iceland, they mostly came from like Norway or like Denmark, stopped maybe in the northern British Isles. Yes. Not necessarily for very noble reasons. Yes. Came to Iceland. And that was the first time that any one of those first arrivers in Iceland had any contact with volcanoes.
Yeah.
Because these areas, although they're beautiful and like diverse in their
And
geology,
have volcanic origins.
yeah, way back when,
It's way back. Yeah.
but not in like modern times.
Mhm.
Yeah, not in historic
I'm just
times.
thinking, like, these people who lived in that area when this happened in 1362. I mean, you're describing it this kind of like, beige, ashy wasteland of like, just wind-blown ash and whatnot. I mean, even the fact that it looked like that compared to all the other places in Iceland, it must have just looked like a different planet entirely.
Yeah. And very, very difficult to be because
Eerie.
the fine ash really gets into your
Yeah.
lungs and
Yeah.
eyes and stuff.
Horrible.
And I mean-
so hence the name
Öræfajökull.
Öræfi,
Yeah.
meaning
Volcano, ruined wasteland.
wasteland.
No, but I mean, it was a wasteland. That is
Yeah.
exactly what Öræfi means. It's like you cannot really stay there or do much.
Yeah. But few people know this. But
Spill the beans.
people came back shortly after, but not the ones that lived there. People came back to like steal things.
Okay.
So the farm areas, we've dug up a farm roughly south of Öræfajökull. You just have the walls and stuff. Didn't have any furniture in it, but inside the wall there was a bunch of things. Like so if you lived there, you used it as a safe. You
Yeah.
had like these personal items put in the wall.
Dashed in behind it.
So the ones that would have lived there would have taken that as well because those are the valuable things. But people that took the furniture and stuff didn't know of it. So you know that after this, people came back just to check if they could take
Yeah.
things.
Oh, look, there's nobody here.
Yeah.
Oh, well.
Oh,
Wow.
yeah. Well, but that's another thing. I mean, this is now like, in recent episodes, there have been so much talk about how history plays a role in geology. And, you're using like, information, not just from the typical field of geology and the data and the science. It's also like you were talking about earlier, the records that were lost.
Yeah.
We're literally also exploring history, and I think
Mhm.
that's so cool how it like combines
Mhm.
these quite seemingly from the outside like very different fields.
And it's like history, like human history wise, it's very long time ago, like 300, 700 years. But it's like such a short time geological wise.
Yeah,
I'm
it's
just
like
exploring yesterday's
Yeah.
eruptions, basically.
Yeah, exactly. That blink of an eye
Yeah.
for Mother Nature. Exactly.
So the eruption that followed that, the 1727 one, was that broadly similar or a bit less?
Less extreme,
Extreme.
and the different eruption. It was like a intermediate one.
Okay.
Yeah.
Oh,
So I'm the only one studying that eruption and still unpublished data. So, but it was like on the flank of the eruption or of the volcano. So technically speaking, if you have a magma chamber or magma chambers, you know that the layering is like basaltic in the bottom, intermediate, and then the rhyolitic one.
Yep.
And volcanoes think in the simplest way, like how can I
easiest
eject?
point of weakness.
Yeah.
Yeah.
So the rhyolitic one goes up.
Yeah.
Because it's like at the top here. Then if you get the intermediate eruptions, they're usually like in the half of the flanks area, and then the
Yeah.
basaltic ones in the periphery.
Yeah.
So
Gotcha.
like they shoot out to the sides, basically
Right.
finding cracks. So this one's the 1727 was in the flanks, sort of upper part, and that was like the intermediate trash can
Yeah.
composition, which
Yeah.
is
Catch-all lava.
yeah. It was a mixture of all kinds of those.
Right. So that's going to
compositions are
dial
different.
down the explosivity quite significantly.
So it was like these fountaining basaltic eruptions, but a little more extreme.
Yeah.
And then short.
So still
short-lived.
bad,
Still bad, but not
but not as bad.
Yeah. Compared to 1362.
Yeah.
So also like, let's say Öræfajökull starts to wake up, we don't necessarily know. Well, that's what I'm trying to figure out. What is the next likely outcome, depending on where in the volcano the activity is. Like, is it to the side? Is it the center? But it's difficult because Öræfajökull is also very steep and it has a glacier. So mapping out the lifting of the land. If there's like the injection, that's trickier.
Okay, so on that note, so we had Kristín Jónsdóttir in recently, and we were talking about
from the Icelandic Met Office.
From the Met Office, who are doing all the monitoring here. And we were talking about the difficulties in being able to monitor certain systems. I mean, some things are actually relatively straightforward and easy to monitor, like what's happening in the Reykjanes Peninsula. For the most part, is dead easy. But then something like Hekla is way harder to actually get any indication of what's going on.
You mean Katla?
No,
Hekla.
Hekla,
Okay,
Hekla as well. Hekla's a horrible one to try and
detect
any kind of stuff going on in. Would Öræfajökull be on the easier or on the more challenging side?
More challenging, definitely.
Yeah,
because we like in that sense we use a lot of like satellite images, and then it's easier if it's like flat land, because then you see
you see the rising.
But if it's steep and you have like also seismic monitors, you need to like they measure depth, and like if you are up high on some place, you need to take that into accountability. You need to correct that. The steepness with the land lifting stuff, that's also difficult. And then you have the glacier on top, which is also just going to null out the movement kind of.
And we talked a little bit about that with Kristín, because like she was saying, like when it comes to, I mean, many of the volcanoes in Iceland are below like Vatnajökull glacier, which is enormous. And you can't really just put the seismic monitorings equipment just on the ice. It would just go into the ice.
Yeah, putting GPS on it is relatively
you would
pointless.
have to find some places where there's bedrock. And that's not anywhere in that region.
Yes, maybe.
Exactly. So there's like few and far between areas where you can actually put this down. Okay.
You need a grid of 3 seismic instruments to form like a one
be able
solid
to triangulate.
point.
So in terms of your research, I mean, I'm not asking you to spill anything that you're not allowed to spill
the tea.
But more like, what is it that you are like, what are the main struggles? What is it that, what's going well, what's maybe not going as well? Where do you need assistance? How could you get that? I'm just curious.
So my research topic is extremely nuanced. Like very, very, very few people in the world are doing this. So it's very challenging, because I am studying experimental petrology. And if someone is listening that knows experimental petrology,
get in touch.
No, they know the struggles.
Oh, right, okay, gotcha.
No, I'm the person you would want to get in touch with. I'm supposed to know all the answers. So that means I am creating. I'm basically, what I'm doing is I'm creating all eruption types of Öræfajökull and then mapping them up in a grid. So like I have created, let's say I've created 300 eruptions of Öræfajökull, all that are possible to happen.
All possible versions.
Yeah, and also versions that are not possible.
Okay.
So in terms of chemistry. So then I need to map out every single...
Is that not just like trying to calculate the number of possible moves in a chess game or something crazy like that?
But basically, I'm doing the same thing you guys are doing here, melting lava, but under very controlled circumstances and in like tiny golden capsules. And then I put, let's say
there's a marketing opportunity. Yeah. Tiny golden capsules of lava.
And then
let's collaborate.
I get like micrograms of an eruption in that.
Yes.
So let's say, just so it's not as confusing, let's say one experiment. I take the 1362 eruption, I've melted it a few times to get it more homogeneous, made it into a powder, and then I have 6 gold capsules, put the same amount of 1362 in each capsule, and then different amount of CO2 and water into each capsule. So like different ratio, the first one has no water, the last one has only water.
Okay.
6 capsules, tiny gold capsules, and then I put them into an experiment. Let's say I want to put it at 2 kilobars, which is 6 kilometers depth.
Right.
And then 950 degrees Celsius. So I let those conditions be for a week or so. And then I have to study each capsule afterwards. So I freeze the capsules in time after the experiment, and then I have different story in each capsule depending on water and CO2 ratio. And then different crystals come up and stuff. So this is extremely tedious or a lot of...
Sounds like a lot of effort.
Yeah. And a lot of things can go wrong. I'm basically making bombs every time. And then I have to study the bombs in detail. Like
microbombs.
Usually people study like 1 eruptions. I'm studying like 300 eruptions or something.
That's really interesting.
So like I have very interesting data and very, very interesting data on a global scale. So I have to finish this because I can't just not finish it. It's too interesting and too cool.
How's it coming along? How much do you have left?
That's always the fun question. Well, I've not been on maternity leave, so like I just put that aside.
You do all this.
So no, I have a baby that I also need to take care of. But
what are you talking about? No.
So I decided just to put the PhD on hold in total, just to focus on the baby because both are full-time jobs. One stays the same as I left it. The other one doesn't.
The other one does not, exactly.
So I wanted to just...
I'm with you there. I'm in that land right now.
Yeah. So now I just need to slowly turn the wheels again soon, not in the next few months or so. But I'm just in the writing process. I have few things left to do analyzing wise, but I basically have all the data, and it's to write it and publish and all of that time that goes into that basically.
And the value of this, I guess, is it's feeding into our understanding of what potentially could happen going forwards.
Yeah. And also just like, then we have a total map of outcomes of Öræfajökull, the composition-wise, and then we can sort of estimate what kind of eruptions and then at what depth things are happening.
Yeah.
So I'm like studying Öræfajökull from within. How deep do things go, and then at what depth do things happen? Like, does it stop at certain depths? Is it one magma chamber? Is it several? What is triggering the other? So like I am studying, by doing all of these gold capsules, I get a full picture of what's going on inside.
Yeah. Wow. That's super cool. Okay, so let's just say history repeats itself. And we get another blowout like we did in 1362.
I'm dealing with all kinds of blowouts these days, mainly diaper related.
Oh yes, I've been there. I've managed that, which is almost 2 years old now. So we're almost past the worst of this.
Yeah.
I think we've.
But yeah, you were saying.
Yeah, but yeah, if this were to, occur again, given the fact that we're living in quite a different world in many ways, what would those impacts potentially be? And, what would the main hazards be to, people in Iceland and beyond, if such a thing were to occur again?
So we, of course, live on a volcanic island, and every rock outside is volcanic. Yep. So it shouldn't be a surprise to us. But since we are living in a human timescale where, let's say, a human becomes 100 years old or something, that is still very short compared to the repetitiveness of these explosive eruptions. So it takes usually a generation to forget this trauma. And let's say if we go back to 1918 with the Katla eruption, which you guys use here, there may be 1 or 2 people left that lived close to that area and is then 110 years old or so, that still has that trauma embedded. But there are very few people left that actually remember this, or hardly any or something. So then this isn't written into our DNA in society.
Yeah.
Like if I talk about the 1362 eruption, I know the scale of it. I'm still explaining it to a person, but the person is not really still
Yeah, you're not
understanding.
connected to
No.
because it's so far in the past.
Doesn't
that
really
it's-
register.
It
No,
might as well
yeah.
have happened in, you
Yeah.
know.
It's similar to when you see a picture of the Milky Way galaxy and there's an arrow like you are here.
Yeah.
You're like, okay,
Yeah.
but you don't really understand
Uh-huh.
the depth of it. So it's not really written into our minds that these things can occur on a daily basis. Like you have to really watch the video at the lava show to really like, okay, yeah, wow,
This is
this
actually
really
scary.
happened here.
Yeah.
Like,
Yeah.
so of course we know that, like we got the Eyjafjallajökull eruption in 2010. Like, wow, we put air traffic on hold and something like that. But that was a small eruption still.
Yeah.
It was a 6-kilometer high plume at best and was bent over, very weak at all times. So like that still affected the whole northern hemisphere. Imagine what another eruption can do, like Öræfajökull, for example. So, I mean, it occurs very rarely compared to a human lifetime, but it will land on some lifetimes still. Like the awakening of Reykjanes Peninsula. I had no idea that that was going to happen in my lifetime.
Yes.
It did. So,
And that just becomes your lived reality then at that point. That's just,
yeah.
you know.
So now we are super used to lava flows and things like that. But if we go 15 years back in time, that was like
Super rare.
super rare.
Yeah.
So let's say we get an explosive eruption of this scale, it's going to have quite the chain reaction of difficulties, just society-wise, and then on the northern hemisphere. And we didn't have airplanes in 1362.
Oh, exactly.
At least I don't know
No.
of that. So then that wasn't a problem at the time, but
Yeah.
would have been today, of course.
But I mean, you said earlier that even if we do not have the greatest records,
Mm.
you know, we are pretty sure that there were some clear signs.
Yeah.
So if we believe that to be true,
Mm-hmm.
you know, we would probably see pretty significant signs
Mhm.
indicating that something was about to happen in, like, soon, very soon. Like in the days and the weeks before,
Yeah.
I assume that there would be strong indications or signals that, you know, may be used to then give an evacuation order to prevent any, you know, at least deaths of
Yeah.
people and animals.
But in that case, we need to have concrete study, which I'm doing.
Exactly.
Because you can't apply the same for all volcanoes. Each volcano is an individual. So you need to know how this volcano behaves. Let's say there were no studies on Öræfajökull and this would occur. People would be like, I mean, yeah, there are earthquakes, but what would it lead to, you know? So then for example, Hekla is very well studied because there have been numerous eruptions. The more eruptions occur, you get to know the volcano more. But then, on the other hand, you need eruptions, which is then not good. So it's like pros and cons. It's good for the science and future, but not good for current situations.
But your study and your research, like because you're talking about volcanoes, I actually kind of like that. You're talking about them as individuals.
Yeah.
You know, and since they are individuals, would you, to some extent, be able to apply your learnings from your study to other similar volcanoes?
Yeah, I could potentially use the same grid for Snæfellsjökull. Not necessarily. There would have, if they are a bit similar, Öræfajökull and Snæfellsjökull, still not the same. So my kind of mapping profile of what I'm doing for Öræfajökull would only apply for Öræfajökull, but I could easily use the same method for another volcano, just like scan through all of the volcanoes, have a full
A
mapping of the
database mapped out. Yeah.
Takes time, but and funding.
Yeah. And again, if you're willing to provide that funding, please get in touch.
No, but I mean, I think it's really, really fascinating what you're doing, and I mean, we are fascinated about this particular eruption. So you know, it's really amazing to get you here to tell us a little bit more about it.
I always speak about it in a very like comical way, like laughing, but then you're like, this is still serious. Like people die,
Okay,
you
so
know.
just to wrap up then, When you stand there,
Yeah.
now, when you're in the area and you're standing there and you're looking at all of this, like, how do you actually feel about that specific volcano?
Yeah, I'm very like kind of spiritual towards nature, you know. I love, you know, seeing the wind blow in the grass and the clouds passing over a mountain or so. But like,
Poetic.
yes, very poetic. But like, especially if it's like a clear sky and the sun is setting maybe and you're by Öræfajökull and then you're like you and me here. It's like it's an individual like telling you to go home. It's getting dark, you know.
Yeah.
But it's yeah, eh, because I work with Öræfajökull underneath. It's very weird picturing what's going on below.
Inside.
Yeah, inside and down, and then like, I mean, you have molten magma there, so it's glowing there, but it's completely dark still. So it's like you go very in depth into science, but don't forget all the aspect of what it is leading to, you know, nature and.
I mean, it's a majestic volcano
Mhm.
and mountain. I mean, it is the highest peak of Iceland.
Mhm.
So for those who are not familiar with Iceland or too familiar with Iceland, Öræfajökull is the highest point in Iceland. I've actually hiked up there. I
Yeah.
did that when I was like 20 or something.
Yeah.
Amazing experience.
Yeah, I did too
The
in like
area
minus
is just-
33.
Yeah.
It's just stunningly beautiful.
It is
that
so
corner of
beautiful.
Iceland as a
Mhm.
whole is just
Absolutely.
really pretty.
So for anyone who's considering coming to Iceland, you know, to visit that region, it's beautiful. I
Yeah.
would not shy away from going there, even if, you know, we have this distant looming danger.
Yeah, exactly.
Yeah.
And,
There will be signs.
And like also the tricky part is you have the Icelandic ring road just like licking the flanks of the
Yeah.
volcano. So
Yes.
that's also like the danger is that you're so close to it. But
Yeah.
if it's like a Hofsjökull, which in the central of Iceland, if there's a threat there, it's nothing next to it really.
Yeah.
So it's so remote.
Yeah.
Excellent. Well, that's probably a good part to wrap things up on. So
Yeah.
a huge thank you, Helga, for coming in talking to us.
Thank you.
That was fantastic. And I'm sure we will be pestering you in the future to come back in and talk about something else as
Yeah,
well.
probably. I'm all yours.
Amazing. No, this was amazing. Thank you so much for
Yeah.
coming.
Thanks for having me.
Okay, that was a fantastic interview. Super glad that we managed to get Helga in for that one.
I mean, she knows her stuff.
She does. And the topic itself, it's again, it's one of these ones that it's kind of on the periphery of a lot of people's understanding when, you know, because it's not necessarily a volcano that really kind of has ever hit the headlines or anything like that. And it just does tend to be pretty much ignored.
Yeah, but it's one of the big ones,
But
and
it
it's
is one of
good
the
to
big
be
ones.
aware. I mean, at times it did become a little bit
A
scary,
little bit.
but
yes.
that's why she's doing the research.
Yeah.
That's why we need to know more so that we can know the signs and do something about it.
Yeah, absolutely. So, yeah. No, we didn't actually invite her. We completely forgot to invite her to share her sort of social media presence and stuff. So that'll be in the show links. So you just click on that and you'll find that in the usual show notes area, as well as any other useful information that we see fit to share with you all. So check out the show notes for that. And if you want to get hold of us on these social media platforms, my social media guru over here.
Yeah, we're basically everywhere. It's like Instagram, TikTok, LinkedIn. You can also just find us on email or on our website. We have plenty of stuff there.
Email us podcast@lavashow.com. So
Yeah.
if you have any fantastic ideas,
Like the bell.
explanation bell.
No, but in full honesty, we love hearing from you. So you know, every time that we get a message or a suggestion or idea, it's really helpful for us to know what you're into. So do not
It's good
be
for us
shy.
to get feedback, just even just to know how we're doing. Like if you think we suck, tell us.
Or
not too
not.
harshly, but yeah, it'd be really nice to hear from a few to kind of get a little bit more of a feel for, you know, maybe what you would like, where you would like things to go. If there's any particular areas of things that you really want to know more about, or you're like, oh yeah, you keep talking about this thing, but you know, what does that actually really mean?
Yeah.
Anything like that, do get in touch with us. We do love hearing from you.
Yeah, for sure. And I mean, you know, hit that follow button. We'd love to have you join the community and listen in on what's coming. There's much in store.
Indeed, there is. All right. Anyway, for this episode, I think we've reached the end of.
Boy, can we talk?
We could keep on going, but we won't. So yeah, if you haven't already subscribed, then do subscribe either in your podcast catching app of choice or on YouTube or whatever. But thank you for joining us for this one, and we hope to see you again next time.
Bye-bye.
Bye.